use the parallelogram method to add vectors. This method is used when we have two or more vectors acting on a single point. So as in the example, we have 55 Newton force acts 30 degrees and a second force of 45 newtons acting 90 degrees on a single point. We want to find the equilibrium. Okay? So again, we start off just like with the triangular method. We need to pick a scale. So with this one, the scale that works well is 1 centimeter is equal to 10 newtons. Okay? We start by drawing up the little bearing symbol. And from there is where we're going to start our vectors. Okay, so first vector is 55 newtons at 30, so we need to measure our angle. We will bring in our protractor. Already set up with the angle of 30. Okay, put it this way, starting at the north again, because it's a bearing, we're going north and 30 degrees. It's right there, so we'll grab our pencil and mark 30, where the 30 degrees is. Okay. Let's remove the protractor. We bring in our ruler, and if it's 55 newtons, then it's going to be 5.5 on our paper. Right, taking 55 divided by 10, that's how we come up with our scale. So lining these up, and just put right at my dot. So taking our arrow, putting our point here, and we're going out to 5.5 centimeters. Okay. Take the ruler away. Let's get rid of this dot if we can. Alright, so there's our first vector. Okay. Probably should label it. This is 55 newtons. And we have an angle of 30 degrees. Okay. Our second vector is 45 newtons acting at an angle of 90. So we need to bring in our ruler, flip it around so it's at 90. Line it up. Okay, so 90 is just straight east. Again, 45 divided by 10, that gives us a length of 4.5 centimeters that we want to draw out. So we take this, 4.5 centimeters is right there. So now we have our two vectors. Again, we should probably label this bottom one. It is 45 newtons. Now, to use the parallelogram method, what we're doing is we're going to build a parallelogram out of these. It's much easier for me to do because I'm using the computer, but essentially what you're going to do is copy this vector and slide it over and create this parallelogram. So I'm just going to copy and paste to make things a little faster. But you would create it the same way as you did before. Stick it over here at the end. And there's you've slid that vector over. Again, they're identical. Okay? Do the same with the bottom one. So we're creating this parallelogram. It's pretty much the last vector here we're drawing. You can just connect the two to make the parallelogram. So we'll put that one up in here. Okay. And what happens with this one, our resultant is going to be the diagonal of the parallelogram. So let's get an arrow here. We'll change colors. Maybe. So to draw in our resultant, we start at, again, the tail, where both tails are, and we go out to where the tips are. And that is the resultant. I will change colors here for you so you can see that a little bit better. Highlight that. Right, so we've changed colors. The result there is the red line. So again, to get our final answer, we will take our ruler and protractor to measure. So having brought in the ruler, lining it up and measuring it, we can take a look. Right up here, it is 8.7 centimeters. So we will write that down. Having a pen, we have 8.7 centimeters. Right? Using our scale, well, 1 centimeters is 10, so 8.7, we're doing times by 10, so we get 87. Our units are newtons for force, so our vector length is 87 newtons. Next, then, we need to do the angle. So angle, bring in your protractor, again, lining it up with 0. We're using an inside scale in this case. 0 lines up with the north line, and going down to our resultant line, and it says it's 122, but looking at our scale, it is 58 degrees. Right? So then we can write that down. Final thing is to write a statement. So this angle was 58 degrees. Right? The question now is, though, asking what is the force that produces equilibrium, right? This force here that we found, 87 newtons at 58 degrees, well, that is the resultant force of these two, right? It is not the equilibrium. Equilibrium is the same magnitude, so it is 87 newtons, but it's going to be opposite direction. So if the equilibrium is opposite direction, it means it's going to be going out this direction. Okay? We know that this here is 58 degrees. Well, in order to get this direction, right, our bearing, well, what we can do, if you notice, this is just a straight line of the two vectors, so we add 180 degrees to our answer. So our equilibrium force is going to be 87 newtons, and the bearing will be 58 plus 183, which is 237 degrees. So as I said, our last thing is our statement. So I just went and typed in the statement. The equilibrium force is 87 newtons at 237 degrees.